Hello everyone. Today we are going to discuss regarding the concrete and the various operations associated with. Now the concrete we have seen it is a homogeneous mixture of coarse aggregates, fine aggregates, then cement as a binding material, water, and if some admixtures are there for the special requirements. So this concrete, uh, how it is mixed, how the placing is carried out, how the compacting is carried out, what is the curing. So all these processes are we are going to study today. So before that also we'll revise the things that we have seen earlier. What is actually concrete ingredients are there. So that we have seen that the what is the mixture of this concrete and what is the constituents is are there. So you can see here the various constituents of the concretes are there. So this is a cement as a binding material, then fine aggregate, coarse aggregates, water. So it is an intimate mixture of binding material, fine aggregate, coarse aggregate, and water. So in spite of the so many compaction and air, so there is a in a concrete mass 3 to 6% air content is there, 10 to 12% cement, 14 to 18% water, 20 to 27% sand, and 40 to 45% aggregate is there. Now, when you add water to this mixture, the this cement the cement reaction takes place. The heat of hydration that takes place. So it evolves the heat, and we have to consider all these factors when you are before you are placing this concrete. So it is understand how the this ingredients or the cementing material that is reacting uh, in the concrete mass. Now, as you know that the concrete, we have seen that it is a very popular material because of its properties. So, concrete that can be used in the huge skyscrapers where a very multi-storied buildings are possible. For road construction, for the road pavement, concrete is the best material. For the construction of the runways in case of airports and, or the pavements, you can say it is very useful. Construction of the dams, concrete is considered as a very best material, suitable material. Then if you see uh, various constituents of this, if you see the cement which is used in this particular mass, it is a binder of a very fine in size, composed of various ratio in of chemicals. Then when water is added to the cement, a hydration reaction occurs and producing a solid gel that bond the aggregate particles together. So that heat of hydration that we'll have to consider. Also, cement is associated with the two types of setting times: initial setting time and final setting time. That also we are going to study afterwards. But initial setting time of cement, when you add water in cement, 30 minutes in the is the time allotted for the initial setting time. So after that it starts gaining its strength. So in the 30 minutes cement is in its semi-solid states, so you can utilize for its placing the concrete. So final setting time it is a 600 minutes, that is 10 hours. So after that maximum strength of the concrete is gained, and thereafter you can say the further we can after 30 minutes it is not advisable to place the concrete. Now aggregates that you are using, it is a inert material, filler materials such as sand or stone uh, used in making the concrete. Aggregates make up 60 to 70% of the total volume of concrete. What is aggregate? Actually, it is obtained from the gravel or rock. Aggregate that must be clean, strong, durable. Angular aggregates particles provide strength due to mechanical interlocking between the particles. So, if the particles are conicals, that voids between the bigger size aggregate, those are filled by the sand should also be well graded, so that so if the all types of particles are present, so interparticle attraction, and they will fill the gap voids in between, and finally the voids between the smaller particles, those are filled by the binding material cement, and that makes the very strong concrete. Now again, more surface and angular particles may form the void or crack. The large size of aggregate is preferred. Okay, aggregate particles should not be larger than the about 20% of thickness of the structure. So these are the some norms which are used at the site. Water, that should be a good water, is essentially essential for the concrete. It should be enough, good enough to drink, and free of trash as organic material and excessive chemicals and minerals. The strength and other properties of concrete is highly dependent upon the amount of water and water cement ratio. If you are using a admixtures, materials added to the concrete beside the cement, water and aggregate to improve the properties of concrete required, admixtures can be divided into two groups as a chemical admixtures and mineral admixtures. So depending upon the requirement, the admixtures can be used. Now this total, if you know about the concrete, the total procedure about the concrete, that you must know how the cement and the concrete manufacturing takes place, and how we are getting the final product. So this process also you must know, that how you are going to get the cement, how you are going to get the concrete. Okay, so what are the constituents of that, and how you are going to get the final product. So all these things are very important. Now the making concrete again, it involves the weighing of all the ingredients for a batch of concrete and mixing them together. Then hand mixing tools are used, or mixing with a stationary paving mixer, mixing with the truck mixers. Okay, this is also. So if you are using a manual method is also available for the mixing. So either before this mixing, the batching of concrete is also carried out. The material, either you can by weighing the material, or by using the volume batching, you can take the material for the batching. So sometimes in the manual batching, a forma is used, and depending upon the grade used, this forma, accordingly the material is taken in the proportion, and it is mixed. Okay, same thing is a machine mixer can be used. So mixing can be done by two methods, by manual mixing and by the this machine mixing. Okay, then pumping and placing concrete is conveyed to the construction site in wheelbarrows, cars, belt conveyors, cranes, by chutes or pump. High rise building, concrete should be placed as near as possible to its final position, placed in the horizontal layers of uniform thickness, and consolidated before placing the next layer. So this is very important. When you are placing the concrete, each layer should be properly compacted or consolidated, and then the next layer is laid, and finishing is done. The concrete must be leveled, and surface made smooth by flat, using the flat trowel finish or broom finish. Okay, exposed aggregate finish. So all these are types of finish where you can uh, give the proper finish to the concrete. Now nowadays, as we have seen earlier, the ready mix concrete is also available. So if the huge amount of concrete is, or mass concrete is necessary, so you can provide the design mix to the such plant, and you can get the ready mix concrete at the site. So such mobile vehicles are there. So these during the transport, or you can say during the travel, this drum keep on rotating, and that will keep the concrete in the semi solid state. So this is how the concrete is placed. You can see this is the reinforcement, and the concrete is placed, and you can see this is concrete is placed by using the chute here. So this is a example where you can find this is by used by ready mix concrete is used by a mobile van. So it is evenly spread, and you can see this is a concrete is leveled here by using these various equipments. Now again, this picture shows is how it is placed in a forma here. This is you can say concrete place for a wall, right? This is a plain cement concrete where the reinforcement is not there. So also you can see for the concrete, for the conveyance of these wheelbarrows and these things are also used to place the concrete. Sometimes if the more distance is there and if it is other methods are inconvenient, then belt conveyors are used. So these belt conveyors are bringing the concrete at the side. So you can see here, and this height should be also given. If you are dropping this, so the height is also very important here. So this on the belt the concrete is transported and which is placed at the side. So we'll have to take care that the proper cover is also maintained during this side, this particular RCC bars you can see. Now if it is not properly compacted, what happens? The honeycomb concrete is obtained. So you can see the various big voids are present here in this. So it is not expected. So what will happen? It will lead to the less proportionate or you can say low strength concrete will be obtained, right? So it is not expected that this each and every gap should be filled, and the reinforcement here you can see it is exposed. At the same time, the cross sectional area of this particular section it is reduced because of these gaps, and this is very detrimental to the structure. You can see here also this kind of also the voids are, and if it is not properly compacted, what is happening? These voids are very harmful to the construction. So for a proper compaction, various vibrators are used. You can say this is a needle vibrator which is called as the internal vibrator is there. It is provided with a compressor unit which supplies the air to this vibrator, and if you put this in the concrete, fresh concrete, so it will give the vibrations to the concrete and it will get a good quality of concrete, dense concrete is obtained. So almost each and every corner can be filled with the concrete because of the vibrations. So vibrator is a best solution on this to get the well compacted concrete. So you can see the in the surface concrete, surface vibrators are there. So here you are observing the vibrator skids. So here you can see a portable equipment. This total you can say bar or this angle is get vibrated, and you can see the quality of concrete you are getting here. Same thing is there if the huge concrete is there. So heavy skids are used. You can see the surrounding here how the finishing is obtained, and it gives huge vibrations, and that will obtain the necessary compacted concrete. So in case of the small works also derbying is also carried out to get the proper finish to the after compacting of course derbying is carried out to give the proper finish to the surface. Then in the floating concrete again you can see this type of power or hand driven floaters are used, and to embed aggregate particles just beneath the surface to remove the slight imperfection, humps and voids, and to connect the motor at the surface in preparation for the additional finishing of the operation. Sometimes what happens in spite of the all these requirements, it is necessary to apply the mortar on the surface, and for the proper finish again you can use these floating vibrators. Also for a smaller finish the troweling is carried out manually. It creates a smooth and hard dense surface. Exterior concretes should not be troweled because it can lead a loss of entrained airs caused by the overworking in the surface, and troweled surfaces can be slippery when wet. So these are the some necessary instructions are there. Curing, when the concrete is placed and after it's gaining its maximum strength, you can say after its final setting, it is necessary after the setting of the concrete, it is kept wet for some days, and that process of keeping continuous wet in the concrete or in damp position, so it is process is called as a curing. So that can be obtained by various methods. it is necessary because uh, to overcome this state of hydration. Not only that, and to avoid the cracks in the concrete. So if you are not properly curing the concrete, then it will lead to the you can say less strength concrete, and sometimes you may not get the required strength. The concrete must not dry out, especially at the young age. Preferably water is applied after the concrete has set. Steam curing applies both heat and moisture, accelerating hydration. Often waterproof barriers are used to hold mixed water, and not as a good wet curing, remember. So all these factors we'll have to consider during curing. So we'll see some pictures here which are leading to the a proper curing methods. So sometimes the water is a scarce resource. In that case, the total concreting surface, it is covered by the necessary covers, so that uh, the moisture which is present in that is not released, it is kept in the inside only. So this will save the water. Okay, so by covering the surfaces, the curing can be obtained. Then okay, you can see sometimes a chemical coating is also carried out on the concreting surfaces. So this coating will keep the water inside only, and the necessary curing results can be obtained. Then ponding method, by providing the ponds on the surface of the concrete. So this will give a good quality, especially it is done for the slabs. Now there are many other methods are there, apart from by spraying the water on the surfaces, by give you can say by providing the gunny bags over the columns, okay, which will keep count in the even in the dry areas. Even the wet straws, those are also kept on the concrete, and those straws are kept wet, so that the moisture is maintained. So if the any precast concrete unit is there, so all the precast units are immersed in the water for some days, and the concrete is good quality of curing is obtained. So all these things are necessary to remember. Now also let's have the glance on the properties of the fresh concrete and hardened concrete. Regarding the fresh concrete, concrete should be such that it can be transported, placed, compacted and finished without harmful segregation. The mix should be maintain its uniformity and not bleed excessively. These are two collectively called as a workability. Now the ease or the easiness by which the concrete can be placed at its place is called as workability of concrete. So this workability is necessary because proper workability will also lead to the good quality of concrete. So in this we have to take care that two properties of a fresh concrete, that one thing is that segregation of concrete. If you are adding more water, the each component or each part of the that concrete will get segregated, separated, so that should not happen. Or sometimes the bleeding of concrete means that when you place the concrete in the format which is you have provided, so this cement slurry comes out, and the rest you can say the rest material will remain there only. So the bleeding movement is the movement and the appearance of the water at the surface of a freshly placed concrete due to settlement of the heavier particles. So the cement material, or can the cement slurry with the water, that will comes out. Okay, so that should be taken care of. So here very important thing that we should keep watch on the workability, and for the getting the workability, optimum water cement ratio should be maintained. So sometimes various tests are also available. A slump cone test is there that you are going to study in future. A slump cone test can be given. A slump is provided and it is filled with the concrete in the necessary layers, and when you pull out this cone, so the slump is measured like this, the height of that slump and the concrete when you take out the slump cone, so this is different. Okay, so that is some IS standards are given that should not violate it. The slump cone test is mostly taken on the site. Now let's have the glance on the properties of the hardened concrete. So the major properties of the hardened concrete are the strength, modulus of elasticity, durability, creep, shrinkage, water tightness, impermeability, and the properties of a hardened concrete dependent on the mix proportion, and which have the greatest effect because of this curing conditions and environment. Now this strength concrete is strength after 28 days, the necessary concrete strength or the compressive strength that must be obtained. Now that depends upon the what type of grade you are using. So in future we are going to study regarding the grade. Modulus of elasticity, that should be under control. Of course we are going to study this afterwards. Durability, the concrete should be durable. Creep or the cracks or this that should not observe in the concrete. Shrinkage, that shrinkage, the reduction in the volume that is not expected, and it should be watertight actually. Okay, so all these parameters we are going to study in future. Compressive strength, generally consider the design of most concrete mixes. Strength properties of concrete in its structure usually estimated using test performed on a small samples made from fresh concrete, as it is placed in a structure which are cured in the laboratory in a standard manner. It is called as a cube test. Compressive strength is done by the many factors, remember. Compressive strength can be affected by the many factors, which are quantity of cement, amount of water, type of ingredients, mix proportion, curing, temperature, age, size and shape of the specimen, test conditions. So all these factors are affecting the strength of the concrete. Okay, if you are not maintaining the proper quantity of the cement, if the according to the grade, so that is going to affect the strength of the concrete. Amount of water, as we have seen, the necessary optimum water cement ratio that should be maintained. Ingredients, those should be according to the specification. Mix proportion, if you want to get the proper strength, so accordingly mix proportion should be maintained. Curing should be carried out in the standard manner. Temperature of the region also going to affect, so we have to take care of that during the as the strength of the concrete goes on increasing with the age. Okay, so that also we have to consider. Size and shape of the specimen depending upon whether it is mass concrete or it is a slim members are there. Okay, and the test condition, under what condition the tests are carried out. Now effect of the type and amount of cement, if you just we have seen the alteration of the quantity and makeup of the paste by varying the amounts of water will give concretes with different compressive strength. Rate of hydration is not same for all types of cement. This is very important, that what type of cement you are going to use, that you will must know what is its setting time. Now cements containing high percentage of tricalcium silicate gain strength much faster than no, the other cements containing the more dicalcium silicate, remember. So this is important, what ingredients are there of the cement. Aggregates, strength of the concrete improves with the increase in the fineness modulus of the fine aggregate, and decrease amount of water improves the compressive strength of the concrete, but that should be also optimum. Larger maximum size coarse aggregates with the lower water requirements can produce strong concrete. Reduction in the water cement ratio improves the strength of the concrete. Using larger aggregates without decrease in amount of water decreases the compressive strength. Strength of concrete could also be affected by the type and size of coarse aggregate. Angular and rough surfaces, textures, particles, those are also affecting the compressive strength. So here it is to obtain the necessary workability, sometimes excessive water is used in the concrete, which is going to affect the strength of the concrete. So it should not happen, because the water which is used in the concrete, that should be according to the water cement ratio, and this water cement ratio is generally 0.5 for the normal concretes. Now effect of the water cement ratio can be seen as this water cement ratio is between the weight of the water and the cement in a water concrete mix. For a proper hydration, water cement should be minimum 0.35, or in the practice it is 0.55 to 0.65 for the workable place, but most of times it is kept as a 0.5 at the side. Increase in the amount of mixing of water while keeping the concrete or the cement content constant would lead to increase the void content and the concrete strength drops. Increase water lead to decrease in the concrete strength. So more excessive water is always harmful, remember. Now, if the proper not if the care is not taken, the voids will remain present in the concrete. Increase in water content, increase the voids in concrete, lowering the durability, water tightness, and the compressive strength. Good dense concrete requires a sufficient amount of cement to achieve the strength and suitable gradation, to minimize the void content, and proper consolidation to remove the air bubbles trapped within the mass. Amount of water should just be enough to guarantee the hydration of all cement grains. A good quality concrete needs to be considered on the following aspects during the concrete making, such as sufficient amount of cement, well graded aggregate, ample compaction, and minimum mixing water. Now also when you are using the concrete, so here we will have to also take care of the necessary steel to take the tensile stresses. So bending stresses in the beam, that we will have to also consider. So this is a simply supported beam where at the, if you can see at the bottom the tensile stresses are there, at the top the compressive stresses are there. So we will have to take care of all this when you are placing the steel in the concrete. So sometimes the pre-stressing is carried out, so especially in the bridges. So what is done after the placing the concrete, so this steel which is used in the reinforcement which is used, it is stressed somewhat, and that will and it is provided with some anchorage at these ends, and it is the those bars are the that particular you can say the pull is released, and because of that it will hold the maximum load. Okay, so the pre-stressed concrete units are used in the bridges or the long span structures. So all these things we will have to remember for a concrete. Also in detail, we are in coming lectures we are going to study regarding the grades of concrete and the various other aspects which are associated with the concrete. So in the future also it is necessary to understand this concrete in depth. So thank you very much for joining this session.